We are required to find the first derivative, which is that part of the question, f stripe x, from first principles. Now that first principles is the key word in this question, because the formula for first principles is this: f stripe x is equal to, you've got a fraction, and above the line you will have f of x plus h minus f of x divided by h. Now that part of the formula is already given to us. However, now you need to remember that since you have got two terms in f of x, you just need to put brackets around them from the beginning. If you don't, somewhere one of the pluses or the minuses will go the wrong way, and then the whole answer will not work out. So just take note that part of the formula has to be given to you for first principles. Anyway, what we need to do is to find f of x plus h. Now, if you look at f of x, it's given as 2x squared minus 5. If they ask you to replace that with x plus h, then obviously we'll just replace that with x plus h as well. So f of x plus h is going to be 2 times by x plus h squared minus 5. Now what we do with that then, since we've got three things that are being multiplied with each other, we've got the 2 from the front of the bracket, and then we've got two sets of brackets that are being multiplied. It's always a good idea to multiply two of these three things first, put your answer in a new set of brackets, and then multiply with the third thing. So I'm going to leave that 2 as the third thing. I'm going to multiply those two brackets out first. So it's x plus h times by x plus h, and I'm going to put my answer in a new set of brackets. So that will be x squared plus 2xh plus h squared. I still have my 2 at the front, and I still have the minus 5 at the back. And now I can multiply that 2 in to the brackets as well, which will then give me 2x squared plus 4xh plus 2h squared minus 5. Now bear in mind that whole expression that I've got there is just simply that part of the formula, f of x plus h. Then I still need to minus 2x squared minus 5. So let me rewrite all of this in the formula for f stripe x. So that will then be 2x squared plus 4xh plus 2h squared minus 5. Then I've got my minus, and then the brackets that I put around my original f of x, because I've noticed two terms there, specifically the one with the minus. So it's 2x squared minus 5. So 2x squared minus 5. That will be the fx part. And then I've got my line, and below the line I've got h. Now above the line I just need to multiply those brackets out as well. I need to do that first. So this will then give me 2x squared plus 4xh plus 2h squared minus 5 minus 2x squared plus 5. And then below the line I still have my h. Now you'll notice that I'm not writing that original limit into this formula, because I want to come back to that at a later stage. So don't worry about the fact that there should actually be a limit of h tends to 0. I'm going to come back to that once we're done with this whole multiplying out of brackets and simplifying the whole expression. Then I'll come back to the importance of that. So for now, just looking at what we've got, you can see that that term and that term will cancel each other out, and that one will cancel each other out. It needs to. The only terms that remain in this expression should be terms that contain h. If they don't, something went wrong earlier in the question. You need to look at that as a checkpoint. If everything that does not contain h is not cancelled out at this stage, something's wrong. So what we have then on the next line will just be that part and that part, which is 4x h plus 2h squared over h. Now before I carry on with that, I want to come back to that part about the limit. That limit of h tends to 0, that needs to stand at the front of your formula. Why this is significant as the limit is that we have h below the line, but we do not want a 0 below the line, yet that is what the limit says. The limit says make h equal to 0, but we can't, because then we'll divide by 0. And that is why we use the concept of a limit. We're saying let's get as close as possible to h equals to 0. That's what a limit means. But in this specific circumstances, we can actually simplify without trying a million of the different values as close to 0 as possible. We can get rid of this anomaly. And the way we do that is to go to that stage there. But now just remember that literally everywhere on every line, you should have your limit of h tends to 0. It should be there, it should be there, and it should be at the end. It should still be there. You need to write this on every single line of your calculation. It needs to be there. So that is where I'm currently standing at. Then the reason why every term that didn't contain h had to cancel out is because right now what I can do above the line is I can take out h as a common factor. So what remains is 4x plus 2h, close the brackets. Below the line I've got an h and I've got my limit of h tends to 0, which is still a problem. However, now those two cancel out. So what happens then on the next line is this. I've got the limit of h tends to 0 of 4x plus 2h. That is all that remains. I don't have an h below the line anymore. It cancelled out, and all I can do now is to make my h equal to 0. So then this becomes 4x plus 2 times by 0. And notice that now I don't use the h limit of h tends to 0 anymore, because I have actually replaced the remaining h's with 0. So now I don't need to write the limit of h tends to 0 anymore, and 2 times by 0 is equal to 0. So my first derivative is just equal to 4x.